Morning, everyone. Thank you for being here. This is the first masterclass from Imaginary Cloud. We plan to be organizing these types of masterclasses on a regular basis, hopefully to cover interesting topics that are technically relevant for our industry. So I think and I hope that this is a good idea, and you can benefit from it, because it's a way for us to actually give back to the community and be able to share some of the knowledge and the things that we learn. And to share that, we'll be inviting people that are often recognized as gatekeepers of a good amount of information in a relevant topic, and they are also known as good communicators. So I'm hereby very pleased to have Xavier Anguera in this talk. He's the Chief Scientist and CTO and co-founder of ELSA Speak, which is a very interesting and now also sound startup, AI startup, very well funded in the US and with a huge audience worldwide. And the technology that Xavier has been building in the last years is really interesting and on cutting edge of this industry. So I'm really happy to have Xavier here for to present this masterclass. So without further ado, Xavier, thank you again for being here, and I'll give you the stage so that you can start sharing your knowledge, which we'll much appreciate. Thank you.
Oh, thank you. Can you hear me, Tiago?
Yes, perfectly.
Okay. I don't see anybody. I don't see myself. So I hope this is actually sending. So hello, everybody. I'm very pleased to be here. Thanks, Tiago, for the introduction. I do hear some echo. Maybe Tiago or Ines, maybe you mute.
I'll put myself on mute. Just give me a second.
Cool. Okay, so I have here a bunch of slides. I wanted to talk to you. The challenge that Tiago posed to me was to talk about AI, what it is, and then to talk about machine learning, what data science is. Talk about a bit about the tools that are used, and maybe also a bit about what we do at ELSA. So before I start any of these talks, given that I don't know what the audience is, and you will forgive me if I'm abusing my prior of your knowledge, I'm going to talk about what people normally understand AI is and what it is not, okay, and what I understand AI is. So if this thing allows me to, okay. So many people, when I talk about AI or the AI comes into the news, nowadays AI is sort of this buzzword. Maybe 2020, aside from COVID, it's going to be AI or it's going to be data science, the big buzzwords, because it's basically getting into the lives of everybody. And now everybody has at home one of those devices that you talk to and you interact with. So people have this very interesting, a very futuristic way that you will be doing these very fancy things with robots and touch screens and all this kind of stuff. At the same time, then starts coming journalists and people out there that start thinking, oh, no, this is not going to be like this. It's actually going to be like this. Those robots will not be nice to us, and they will be actually taking our jobs, or you know, there's going to be like this guy, this gentleman down here, even though he has a lot of money, so some of his ideas are a little bit out of the normal, that says, you know, AI is very dangerous. Other people, they even go further, where they have watched some sci-fi movies and they think that those robots or those AI agents will actually turn against us. They will learn too much and they will basically we'll have to fight for our existence. Well, nothing close to that. I am actually thinking of AI. Oh yeah, this is another example. This is from that movie, the 2020 Space Odyssey, or 2021 Space Odyssey. this guy, this robot called HAL that turned against the passenger in the aircraft, right? So nothing like that. I'm thinking of AI like this movie. I don't know if you haven't watched it. I recommend it. It's very nice, at least if you like this sort of sci-fi movies, where AI is this companion that doesn't oppose us, doesn't stay in front of us, but it's sort of ubiquitous and it sort of enhances us. And how does it enhance us? And how is this developing nowadays? Well, we can see devices at home where they are just sitting there. I know it's a little bit creepy. Something is listening to us. We can go into detail then later on why they are not actually listening or when are they listening, but they're sort of there. And we just talk our thought, and then they pick it up and then give us some answer. Now, the quality of the answer, that's what AI is able to keep progressing over time. Down here, Google, I mean, yeah, you don't realize, but there is a lot of AI machine learning behind this. And the fact that when you type something, you sometimes explain it in totally natural language processing, natural language, and then it processes it behind and it gives you the most relevant content. Nowadays, it will also give you a lot of ads, but anyway, that's sort of a counterpart of how do they make money out of making these products, right? Other things like we've all have in the cars now these navigation devices, either in our phone or embedded in the car. I remember 20 years ago, I got lost in the desert of Death Valley in the US because I had a paper map and I didn't interpret pretty well the signs, and then I didn't know whether I was in the right direction or not. Nowadays, that will never happen again unless the battery dies out in the phone. And things that we don't normally see yet, but we will see, and some examples are augmented reality things. Like, for example, yesterday I was watching a video where you can play these sort of card games of the role-playing games where you have little animals there and with different powers, and you put it in front of the cell phone, and then it sort of gets to life, and you can see the animal fights with another one. So these sort of cute things, right? Not really as useful as the others, but it's nonetheless, it's a lot of image processing, a lot of artificial reality, artificial intelligence, etc., etc. So in this talk, I'll be talking about, I'll be aiming at three things. This is my objective of the talk, to give you some knowledge about specifically what algorithms are in the AI world. I will go down, I will show you formulas. Don't be afraid, easy ones, and you don't really need to know them. But I'll give you a little bit of that for those of you that are interested in that part of AI. I'll give you applications that go from things that go with robots, things that go with speech, and also intersection of AI with a little bit UX, UIs for people that are less technical but are interested on the usability part of it. And then I'll tell you a bit about tools, ways that you can create AI applications, create machine learning models, and what's out there, what the vendors are offering nowadays. Is a bunch of cloud vendors there that are offering us very nice, interesting tools to use, always at a price, logically. So very simple, two parts of the talk: what's data science, machine learning, and AI with all these applications and tools. And then in the second part, I'll talk a bit about what we do at ELSA using machine learning, using AI, lots of speech processing. So I'll talk about what speech is and how do we process it. And I hope that's enough, and you can always contact me later on with comments, questions, etc. So first of all, of course, Tiago already introduced me in one of those, very grandiose ways, but well, this is me. Very simple. I'm from Tarragona. It's a city in Spain, but in the area of Catalonia. I did a master's in telecommunications, then a PhD in speech processing between Barcelona and the US. I worked for several big companies, Panasonic, Telefonica, doing research, R&D for over 10 years. Then I switched into entrepreneurship. I came to Portugal and I started, this is my second startup. what I call officially startup. I collaborated with others before, but wasn't really 100% on those. Yeah, I'm based here in Lisbon. I don't know where you guys are, but based here in Lisbon. I hope when COVID goes away, we can see each other again in person. So let's go into the deep into what data science, what machine learning, what AI means. And there's nothing better than starting with our maybe data scientist here, our robot from the Star Wars, introducing us or the definitions of artificial intelligence, machine learning, and deep learning. We'll define later what a data scientist is. So artificial intelligence is a very broad concept, a very high level concept, which is basically defines this intelligent behavior that a machine will exert in order to solve some problem, right? This intelligence is not just you telling the machine, yeah, if this, do that, then else. No, it's the rules that allow this machine to solve this problem are learned in whatever way through algorithms. Okay, those algorithms, how to learn that is that's why we use machine learning. Machine learning are all these methods that will help us learn this behavior, and most importantly is it's going to learn from past behaviors to infer what they have to do next, even if sometimes they haven't seen that exact problem. They just have seen lots of similar problems around it in the past. So this is sort of what gives it a bit of intelligence. Okay. Now, as time progresses and as the area has become mature, and most importantly, we have lots of more training data and we have lots of more machine compute, we have the area of deep learning that came in, which is how we train the machine learning, but in a way that is inspired by how the brain works. So we'll go into that. It's how the cells in the brain, the neurons work. They translated that into a model, into a machine that we train with deep learning techniques. So AI is this big thing, then machine learning is a subset of it, and deep learning is a subset of machine learning. Okay. Now, there is a lot of different areas in the current society where AI is applied, or companies claim that AI is applied. You can find examples anywhere. You go to the media nowadays, and there is articles in every single newspaper every day. You have several articles talking about how this company or how that have solved this, have solved that with AI. Now, be aware, not everything that glitters is gold. It means that yes, there is very interesting applications. Yes, people are solving things, but many times what's under the hood of an AI flag, it's not really anything else than a logic, if else logic, which is definitely not AI. In fact, if I can go back to my slides here, in fact, some time ago, this report was saying that in Europe, 40% of AI startups that claim that they are AI, they are actually not AI. And why is that? Well, because it has become, maybe this fuzz is some sort of dying now, stabilizing, but it became fashionable for any company that was looking for funding, looking for money, to just either get a URL that finishes with .ai, or claim that they're doing AI in one way or the other, and that's fashionable, right? And that gets investors, oh wow, yeah, I need to see this startup and I need to invest on it. And that was a trick that was played a lot, even though many times they were just calling an API from somebody else that they do some AI, but they just not do anything themselves. Okay. Let's go deeper into that, and let's let's go into the machine learning, which is, AI. We've seen the concept. Now let's go deep into, okay, how do we actually train systems? And you'll see it's not that complicated. It's big, but it's not that complicated. So we define machine learning in some way. This is another definition. Say machine learning defines techniques that build models from sample data, and to do tasks that they were not explicitly trained for, as I said before. There's plenty of applications. I mean, we see here automatic language translation. There is this company Unbubble here in town doing it very well. Image recognition, speech recognition, and other things. Stock market trading. It's a very long time type of application of AI, which has evolved a lot over the last few years. Online fraud detection, etc., etc. Tons of different applications. And how about techniques? So machine learning has this sort of, I would say, two main branches: supervised learning and supervised learning. Then we have a third branch, reinforcement learning. We'll talk about it. This became fashionable the last few years, but you know, I wouldn't trust all my money into this, and I'll tell you why. And then you can always mix match, and from supervised and unsupervised, you can do semi-supervised, where there is some supervision and then there is also some automated learning. Any one of these has lots of different things, and we'll see classification and regression in a second. Unsupervised, you have clustering, you have dimensionality reduction. We'll talk about this a bit. So let's go. Supervised learning, what it is? Well, I mean, the word gives it up, right? So in supervised learning, we have training data, and we have, together with the training data, a label or a value or whatever it is that we want that data to represent or to end up giving us. In this case, we have a bunch of animals, and we have with them a label that tells us what type of animal it is, right? And what we want with this model is that we train the model saying, okay, the first one is a duck, second one is a duck, third one is a rabbit, fourth one is a porcupine, and with a bunch of features that we extract, not only just the image, we could just be the image, but image plus other features, and then we learn this predictive model. Now, with this predictive model in test time, we will take a random image or a random set of features extracted from our specific case, and we will ask the model to tell us, okay, from those labels we gave you on the training set, tell us which label is most appropriate for this one. And in this case, it's duck. Very well, it matched it. And this is applied to many types of problems. Okay, the input data can be audio, can be images, can be just tabular data, so n-dimensional tables, anything you can imagine, provided that you have training data that has associated the tag, an extra column in this tabular data, if you might, that has the output that the target that you expect, the target that you desire. This target can be categorical, like in here, you have certain categories. Can be, well, actually here you have duck, no duck, so it's like two categories, or you can have duck, rabbit, porcupine, whatever, so it gives you the multi-categories. It can be a number, from 0 to 1, 0 to 100, whatever, one number, and it will estimate what the number is. It can be many things. Second one, unsupervised learning. So what happens in real life? In real life, it happens a lot that it is expensive to create the labeled data. So in real life, you have sensors. Imagine in our case, in ELSA, we record a lot of people's speech. So you have a lot of audio, or you have a camera, it records in the street, lots of images, or whatever, a sensor that records temperature, records stock options, whatever, stocks. And all these data don't necessarily have a column that is the tag, that is the target. So you have the data, but you don't know what it is about. And then some people venture themselves into going into Amazon Mechanical Turk, or in other ways. There is a very nice company in town called Define Crowd that they do that for a living, and they try to label that data. So they do the acquisition, and then they do the labeling either themselves or with the crowd, and then they have the label. They have a supervised technique. If you cannot do that because your data is too big or other reason, or you're just exploring the data to see what's in there, you can do unsupervised learning techniques, which is where you just, from the data, you let the systems look at the data, look at the different dimensions, and try to infer properties that differentiate the data into subgroups. So, or that do something, but totally without this target dimension. And in this case, the clustering, what I was saying before, will cluster the animals into the different types of animals, and it will look at things automatically. We will not tell you, but we look at things, for example, that, oh, the ducks have a mouth, have the beak, the rabbits have ears, porcupine is more rounded, whatever. I mean, it will find it itself if we have the right features extracted a priori, of course, if the data is complete, has relevant features. And finally, I said, be aware of reinforcement learning. No, reinforcement learning is there. Reinforcement learning works. It's a very nice, very hype type of algorithms. Mostly they got their hype when Google Mind started creating applications, or I would say PR, like applications to show off their technology, like AlphaGo. And what it is, it's basically a machine learning system. In this case, it would be the mouse, a machine learning system that doesn't know anything a priori. Everything is random. He can do whatever, but he just decides to take an action. Takes an action on a certain environment or a certain problem. Then what's important is that this action returns to him a reward, so he sees whether the action was successful or not in one way or the other. There is different ways that we can create a function that defines what the reward is, and an observation of what's the state, what's the situation in the problem after he has taken the action. That helps the animal, the machine learning, the animal in this case, helps him learn from that. So, okay, I did well, I did bad from the reward, and this is the state that I ended up being, and that helps him learn. So what do they do? What did Google Mind do? It's they put a machine to play Go for thousands and thousands and thousands of hours. They've done it also with Warcraft, I think, and with some other games, and they let it work. You have to define the reward very well, or if not, it's a highly possible that it will just not converge to anything. But if you do it well, it will converge to a system that learns by himself, and that's very, very high. Like, whoa, you know, a real general artificial intelligence, what they call it, general artificial intelligence is where you don't really need them to give them label data. They just go into the world, figure it out, and that's what sort of people then started thinking about those robots that will turn against us. But nothing out of the extraordinary. These systems, they will learn that specific problem, and hopefully they will learn it well. Hopefully, because it takes a lot of effort to define reward, define everything here, so that it actually doesn't blow up and doesn't just turn to nothing. Okay, so be careful with reinforcement learning. Sometimes works, sometimes it won't work. Going back to, I would like to focalize a bit on the other two parts, supervised and unsupervised, which is, I think, those that most people that are doing data science are using and will use, and tell you a bit about the most typical examples, types of algorithms you will see, and how to measure their progress, how to measure their accuracy, etc., etc. So 3 types of algorithms: classification, regression, and clustering. So classification, as the name says, you have classes, as we said, the rabbits and the ducks and the porcupines. In this case, spam filtering. You have emails that are spam, emails that are not spam. You label them manually. Then you train a system to learn from the data what is spam and what is not spam. And then for any given new email, you can classify the email into one or the other. You can imagine Google is doing it very, very well, but you, from time to time, you go to the spam folder and you see emails there that, oh, this is not spam. So you have to put it into the non-spam folder. And that's important because Google then can learn that that type of emails for you are not spam. So it can adjust. Regression problems is a similar problem. You have data, you have a target class, and then what the system does is to predict for a new set of data what the target would be. And this is not to classify it, but is to give you some sort of gradual, let's say a number, let's say any sort of property that is not categorical, okay? And in this case, for example, the regression problem here is the house prices. So you can give it location, I don't know, whether there is bus lines or metro lines around, what's the per capita price of the per capita capacity of the people around there, etc., and that will give you a proposed price. And if you go to these big companies that sell you houses, the immobiliarias, I don't know the English, they sometimes have this sort of thing in their website, so you can play around with it. Third class, I mentioned before, clustering. You have data, you don't have target labels, you have data, you let it go, and this is nice because it allows you to visualize things in the data. Then you can maybe use this, and this is where a supervised and unsupervised go together. You can use this to yourself very quickly, annotate it, C1, C2, C3, train a classification model and run it and see, then visualize again and see if it actually is working, or adjust yourself. So there is a bunch of inbreeding here between supervised and unsupervised into semi-supervised models. There's tons of algorithms out there. Supervised and supervised. This is a slide I took from online. I haven't tried all of them. But you have the most typical ones, the very simple ones are the first ones, linear regression, logistic regression, very simple to train, very simple to start from, and k-means is a totally unsupervised way to separate things. And you have like all other more decision trees or super vector machines, FVMs. The other day, somebody asked me about quantum computing. I did check it out, because if you see this here in the first column in regression, there is actually no computers that do quantum computing, or there is only prototypes, but there is already papers that say how you can do regression with quantum computing. So it's interesting, and it's one of possible algorithms. Here, I would like to talk to you, before I jump into deeper, and never saying better, deeper into machine learning, so into deep models, deep neural networks, I would like to explain to you so you understand why we need that. Okay, why we need deeper networks, why we need deep learning. And this all has to do with the machine learning model capacity. So the model capacity is the capacity of our model, like depending on how simple or how complicated the model is the capacity of that model to learn from the data we give to him. So if we only have 3 or 4 samples that we can label, or I don't know, a dozen of them, forget about deep learning. I mean, deep learning will never work for you. So if you look at the data, if you see the lower part here, the blue, it will give you very bad performance if you have very little data. Now, traditional machine learning models like, I don't know, super vector machines or regressions or logistic regressions or linear regressions, they will work for you. They will work from only a few dozen samples. So you can go label things for half an hour, and you already have something. Now, that's something. These models are simple, and as the data grows, the models will max out. They cannot do more. They cannot excel more than that. Okay, and so there you have to start thinking about going into neural networks, which has a much bigger capacity. And we'll see the difference between neural networks and deep learning, but you'll see that at some point neural networks just take off and they are able to learn, but they also max out at some point, right? And then that's when you go into deep learning, and then you just keep going, the curve goes up. And actually the deep learning curve, yeah, it is curving, but it's actually nowadays we still put in more and more and more data and see that if we put more and more and more layers, it actually learns more and more and more. So I don't know where we're going to get into this. I don't know if they're going to max out and we're going to get some other curve come after that. But for now, deep learning is the one model that if we have lots and lots of data, is the one model to go. And sometimes people, and that's an idea you might have, they start with small data they label, and they start this curve. And then as when they have enough data, they use those labels, maybe they verify them manually, and they start the other curve, and so on and so forth, so that they don't have to have a huge labeling effort at start, and they have the help of the semi-supervised labeling. So let's go into deep learning, and let's go into the brain. So you have here down on the left what's a very simplistic picture of a brain cell, of a neuron. A while ago in the Gulbenkian, there was a very nice exposition, very nice showing of the brain, and they had a huge neuron in there. I mean, if any of you went there, you'll see what I'm talking about. If you're connecting from somewhere else, yeah, was in Lisbon. It's a nice museum that people they have very nice expositions there. So anyway, going into the brain, I need to explain what that is. Well, at some point, scientists started thinking, okay, look, if we want to make artificial intelligence, why don't we try to replicate the real intelligence we have, which is our brain? So they started trying to mimic how these neurons work in algorithms or in units that they can then put into an algorithm, train and put into the model. And that's how artificial neural networks, ANNs, started. Those are actually pretty old, 80s or even older than that, the first people that talked about that. Now, the problem is at that time, I even had part of my PhD was done with somebody that had done it in the 80s for speech. But at that time, there was not enough data. So having a few hours of labeled data was already huge, and there was not enough computation. Imagine the computers you had when you, on the 80s, you couldn't train any of these. So as time progresses, and now that sort of came, this wave of deep neural networks came actually on the late 2000s, 2009, 2010, we realized, oh, now we can do it on, we can actually label or have even unlabeled data, lots of it, because we have the capacity to store it, we have the capacity to process it. And that's how this deep learning revolution has came to be. And that's basically taken everything by slide. Everything now is deep learning, everything. So going more into detail, this is on the right, this is an illustration of what a neuron is, and we have millions of those in a deep learning model. So what the neuron does is basically, excuse me, it has all the inputs, which are what it's equivalent to the dendrites of our neuron, and all these inputs, they come from previous neurons, and each one of these inputs is weighted. These weights are trained to be optimal, and then they are combined, just a weighted sum. And finally, we have the activation function, which decides whether this neuron is going to fire or not. In here, the same thing. So the dendrites come in, the neuron does something here, biologically does something, and if it decides to fire, it will send a small electrical pulse to other neurons that are connected through the axon. Okay, so in this activation function, this is a tangential, hyperbolic tangential, or a sigmoid, or whatever, one possible function. It will decide to fire or not depending on the result of this sum. And this is the output that is connected to, is the input to some other, to one or more than one other neurons. So as simple as that. Now, it comes interesting when we start having, so each one of these balls is one of the neurons that I talked to you about. So you start having neurons that connect to lots of neurons. And so this is a very simple model for deep learning. And why is deep? Because we have hidden layers. These are hidden layers. Do you see my mouse? Do I maybe? Never mind. I think you'll notice. Oops, here. So it's my first time using this webinar application. So input layer, all the input layers, the input signals, make it speech, make it temperature, make it image. Image would be the pixels with the different colors, anything. And then the hidden layers, that's what makes it deep neural networks, so deep artificial neural networks. And then the output layer that takes the decision. It can be one output layer, it can be many output layers, depends on your application. And this whole thing is trained with an algorithm called backpropagation, which is nothing than you have an input and you have an output. So training data, you know the input and the output. You do a forward pass where the input goes and gets all the values from all the neurons and you get the output. and then you compare the output that the network gives you. You compare it to the expected output, and then you do the backpropagation pass, which is I adjust just a little tiny bit, and that can vary, depends on the algorithms. It will be modified or not. I adjust all the weights backwards so that the output gets a little bit closer to the expected output. And you do it in batches, you do it for lots of data, and you'll see that the network learns. And that's something that Geoffrey Hinton started with already, I think, in the late 80s, 90s, and then it has become the de facto way of training neural networks. Okay, here. So a bigger neural network look like this. They are a mess. Everything connects with everything, but there is many different types of that. These are the fully connected neural networks. And here to explain to you, the neural network has been seen as a black box. You know the input, you know the output, you don't know what happens inside. There is an area of science that's machine learning explainability that tries to explain a bit better what happens inside the neural networks, and that's good, so that we know what we can expect. For example, in financial risk applications, you really need to know why is the network not giving you the mortgage, because you need to explain that to the client, right? But still, the neural network will take a decision. And in image, for example, what we know is that a neural network, from the input, which would be a full image, every layer will focus on a specific level of detail. So here, for example, the first layer will just go at the edges. This is an example, right? Second layer will go at combination of edges, so this part of the parts of the body and of the face, and then the final layers will be looking at different possible faces or eigen faces, or some possible faces, maybe nothing to do with the original one, but faces that could be. For example, you've seen many times that neural networks can invent people. They just output possible people based on some input or based on noise? They just invent people. So that's one possible application. Okay, enough of machine learning. We'll go back to it in a second when I tell you how to measure it. But let's define the third thing. So we've the fourth thing. We've defined artificial intelligence, machine learning, deep learning, and then a bit on the side, what is data science? Because some of you are data scientists, some of you want to be, some of you are interested on what it is because you've heard it around. So let's define it. And this is the least mathematical or the least technical of those, because this is sort of a profession, like, okay, data scientists do data science. So data science defines this buzzword, this buzzword that defines the intersection of people that know math and statistics, they know programming, they know computer science, and they have deep knowledge on the domain they are working on. So being it a business domain, being it whatever specific domain that they want to apply their knowledge to, okay? So this is a nice visualization of what a data scientist is, the modern data science, okay? And you will see here that there is no longer the image of a nerd locked into his cubicle with those horrible big mugs and in his computer programming, right? It's more modern people, nice jackets, nice things. Why? Because they have a lot of communication and visualization. That they need to do. They need to talk to the clients. But a big part of the data scientist's work is to talk to the client. Another big part is going to be getting the data. So programming, they have to know database programming. They have to know some machine learning, math statistics, so that they can actually derive knowledge out of the content. So this is those guys that bridge the gap between what the CEO wants and what the nerd has. Okay, let's say for you to understand. Common tasks that a data scientist does, and this is from the web, but I found it very interesting. So the question that the business people will ask is, how likely is this consumer to respond to our campaign, or how much will she use the service, or can we find consumers similar to my best consumers? This is what the CEO is interested on, okay? And then what the data scientist translates it into is on the bold ones, which is, okay, is the instance satisfiable or not, or how long will the solver run to solve the instance? Sorry, no. So what the data scientist will go is translate it into a problem of classification, a regression problem, or similarity, or clustering. Okay, and these are how he does it. So it does algorithm selection or does clustering. Okay, so let's go to the data scientist project. So what do we do with what do data science does on a day-to-day basis? And there is also here, let's say, an imaginarium of what the data scientist does and the reality. Okay, and we'll see why. So first of all, the data scientist needs to speak to the client, needs to speak to the CEO and understand what is it that they want. Is it to know which clients are gonna pay the most, which clients I have to target in my next marketing campaign, whatever. Then once he gets the goal, he needs to go and see, okay, what do I need? What data do I need to process? Okay, so he goes and gets sales, real sales, or network inputs, or speech, or image, whatever. Next thing is he's going to clean that data, and this is where there is a lot of this. Some people say that 80% of the time goes into this category, because data is nice. I have data. I have a gigabyte of archives, but is that data actually usable? Many times it's not. Sometimes there is fields that have values, fields that don't have values, other fields that have intermixed values, some categorical, some numbers, some other fields as simple as some are capitalized, some are not capitalized. What do you do? It's not the same thing. Yeah, for you it is, but it's not for the machine, etc., etc. So you clean the data. Sometimes you enrich the data, meaning if you know the day that something happens in the street, you might want to check the weather forecast and see if it was raining, so you know whether the cars might have been stuck more in traffic or not, etc., etc. And then once you have enriched data, you actually have data. That's when your fancy work starts. That's where you get your IPython notebook or your SQL queries or whatever, and try to find insights, try to find knowledge. Okay, visualize it, show it to your customer, etc., etc. Once the customer is happy, once you are happy, you found whatever you want, then you can deploy your machine learning model. You can put it in production and tell to the customer, okay, now you give me a new input, and I'll tell you a forecast, or I'll tell you what type of input it is, classify, etc., etc. And of course, you will always want to iterate, either from the data collection or from the finding insights or anywhere else, or to go back to the customer and say, hey, this thing you asked me to do is impossible. I need to do it in another way. Hopefully not, but anyway. I'll skip that in interest of time, just to tell you that it is very important for you to take the data seriously and not train on the same data you're going to test. If you train on the same data you're going to test, you're going to have perfect results and are not matched with your reality. Also, if you train on data, put it in production, and then forget about the model, you will start getting bad results at some point when the situation, the reality changes. World changes constantly. Your data you are acquiring changes constantly. So this is just to keep it in mind. And a little bit more in detail what we said before, where we talked about supervised learning. There is a part where you train the model, where you have labels where you know what you're expecting, and then there is a part where you have test data, and you do the same process, except that you're using the model you trained before, and then you predict the output. Either either a regression or a classification output. This is a supervised way, not unsupervised. Here, a bit of math, as I promised. How do we measure these systems? How do we know we are doing well? So how do we use this test data to see how our model is doing that we train with the training data? There is a bunch of methods, and depends on the problem you have at hand. In supervised learning, regression and classification, the two main that I talked about, you have metrics like the R square or the mean square error, the root mean square error, that will tell you how close your prediction is to the actual data, how close the actual data is to your prediction. I'm sorry. Classification, you'll have accuracy of classification, F1 score, area under the curve for either binary or multi-class model. And in clustering, you have an example of clustering here, where you have a blob, initially a blob of points, and then you have to classify them into groups. Sometimes you might know how many, sometimes you might not know how many. You can look at Bayesian information criterion or archaic information criterion, things like that. Just to go a bit more into detail, these very fancy names, mean square error, root mean square error, is nothing more than averaging out the difference between the actual value and your prediction. So it's formulas in one way or the other. Each one has their property to see how much you're deviating from the reality. In classification problems, it goes a little bit more complicated because you can have false positive, false negative, true positives, true negatives. What is it? True positives is what you are correctly predicting as that is going to happen, and it actually happens. True negatives is you're predicting correctly that's not what that is not, and it's actually not, and then you have the two counterparts. And then you can define prediction and recall, F1 score, by combining these things. And accuracy is the simplest of those, is how many times you correctly classified it versus how many classifications you have done. And to understand it a little bit better, this is a very nice picture, a bit outdated, but very nice picture, where you can have two types of errors. You have false positives, that's where you actually are saying something is one way and it actually is not, it cannot be, so this guy cannot be pregnant. Or false negatives, you're saying no, it is not, the classification doesn't classify doesn't classify it, and then it is clear that it is this woman is pregnant. Well, unless this is a basketball. Another way I render the curve, let's skip it. It's a way for you to find an optimal working point given all possible true positives and false positives. So let's go into the tools. Let's go into how do we realize all that? How do we do all that? So my hope, my expectation is that you will learn in here some tools and some tricks that you might not know until now. How do we normally program machine learning models or do data science? Nowadays, Python is the #1 that comes from computer scientists. But then if you come in from the business side and you are a BI analyst, you'll most probably use SQL. So these, for me, are sort of the equivalent to top very nice methods. And they deal with totally different aspects. I haven't defined what the business intelligence person is, and I'm not going to go in that way. But knowing SQL is very important, and having databases that have all the data well entered can give you a lot of information. When that's not the case, when you're working with raw data or you want to create your pure machine learning algorithms like regression classification, you have to use R, Python, these sort of techniques. Okay, there is many others. JavaScript, you can do machine learning in JavaScript. You can, if you have lots of data scale, people use Scala a lot. Rust has come to be pretty relevant lately, which is a language that avoids some of the problems that Python brings, because Rust is a strong type. So you don't get those errors that are very difficult to track. It's going to complain to you. It's like C, but not with not such low level. It's an intermediate between C and Python and Julia. Somebody asked me, can we do machine learning with JavaScript? Yeah, we can. And we have TensorFlow.js that runs on the browser. You can get some of the GPU power from the computer through that, but it has its limitations. It's single-threaded. It has limitations. I wouldn't do it. I would go use, if you're starting now, I would go use Python for machine learning. And then once you know a lot of it, or you have a certain application in mind, I would go look into how do I do edge computing, maybe with JavaScript type application. And then Python, as I said, Python, I recommend it. There is, these are your friends that will make your life much easier. You don't want to code everything. There's lots of it that is already there. You just want to use the libraries that allow you to be faster. So what you want is to put your intelligence in that, not to put all the coding on how to do a linear regression or how to deal with data. So the basic libraries on machine learning part, on how to deal with data with pandas, how to visualize with matplotlib, and then frameworks that bring you a lot of the machine learning guts. TensorFlow is very famous, PyTorch is very famous within the research community, and you have lots of others, okay? Environments for programming. So environments means, okay, how do I, in my computer, what do I run? Where do I run Python? How do I program it, right? So you have all the traditional tools that you can have. I mean, you have your IDE, you can even program in VI if you want. And then you have web-based tools. And web-based tools have I'll show you here, Jupyter Notebooks principally and Google Colab. These are IDEs that are specifically thought for data science. Why? Because they sorry, they allow you to collaborate between people. People can see your modifications right away. They allow you to use to visualize in between your code. You don't need to close the code, compile, run, or go to the terminal, run. It's just, you just see it there. It's sort of a notebook where you see formulas, math. You can put text, you can put images, etc., etc. So it's very nice when you are doing these visualization or this discovery on your data. Sometimes, so I put GPUs, TPUs. It allows you to run on this. If you're running Jupyter and on your own server, of course, but if you're running Google Colab, which is a totally hosted by Google, they allow you to use GPU sometime, right? So this is IPython, this is Colab. In Colab, you can go set up and you can use GPU, so your code can run on GPUs for free. Okay, don't expect that this is stable and will last for you for weeks. No, this is for if you run things. Okay, have an hour training, fantastic, you can do it. If you're starting, if you're and you don't have a strong predilection, okay, I have my own idea, I want to use that, this is a great way to start, and it's a great way to get your foot in. So I recommend it. How are we doing with time? Okay, fine. So end-to-end commercial tools. So I wanted to go a little bit in detail with all those things I talked to you, is things that you download or you go online and go create a Colab notebook. And those most of them are for free. So it's totally open source. But then that still doesn't solve your problem of, okay, where do I run it on, right? If you have your own computer, your own laptop or your own home computer, fine, that's going to get you somewhere. But if you want to start training things with a lot of data, that's going to be a problem. If you want to start having that deployed somewhere, you'll need a server online. How do you put your machine learning model into a server? All these things. So of course, the big players have thought of a pipeline of ways for you to do that very simply. You just need a credit card. Okay. So what's the life cycle or how you do? So with normal machine learning models, normal data science models that you want to put into production, first you're going to get data, right? You're going to have a way, you need ways to get data from your reality, from your world. You want to store the data or transfer the data in a place where it can be then processed, and this can be into a database where you would do SQL on it, or some data lake where you then pull from it and do inference on it or whatever. The processing part, we talked about all the machine learning models, and then how do you output the results? And this can be how do you output to your marketing team with nice graphics and nice figures, or how do you show to your CEO, or how do you what do you do with the results of that, right? Okay, so let's go a bit into each one of those and what's out there that I've used or I've evaluated to use in my company. This is a very, very, very tiny picture of what the current market is offering. Okay, I mean, this is very, very biased. You will probably know a lot more others that I'm not mentioning here. I'm trying to be. I have tried to put some of the ones that I think are the top players, but anyway. How do you ingest data? How does it mean? Well, you have either applications running in iOS and Android, or sensors, or web page, or whatever. How does that go and gets piped into your inner guts databases or your inner machine learning model? So there is companies like Segment.io down here. This is the big player. RudderStack, I love them. Open source. They have an open source and a paid version. This one here on the right. That allow you to pipe things very visual from one place to the other, and then it can go into the very standard, typical tools that can analyze this data or databases, etc. And then we have other Stitch, Panoply that I've looked in the past, never used them. Then all that data, it goes somewhere. It can go into some processors, or it can go into some databases. These are databases. I've used Redshift and BigQuery. They are great. The SQL based. You have to always define your tables, but they are fast. They are scalable. They are data oriented. They are data science oriented. Never used Snowflake. Heard very good things of it. It's run by its own company. These ones are from Google and Amazon, so they come in sort of as the setup is very integrated with all the Amazon and Google tools. This one here, you need to see how to integrate. I'm sure it's easy. Never used it. Data processing, so machine learning. This is huge. Okay, so how do we do what we have the data? What do we do with it, right? I here wanted to have a bit of you see the three big players: Amazon, Azure, Google Cloud, and I want to talk a bit about when do we want to use it and when do we not want to use it. Okay, so these are all these online services. They have the pros that they made everything that is standard. They made it very easy for you, very easy. Many times you don't need any programming skill. You have access to infinite computation. If you need it, you just click and boom, it scales. So you can process the data, you can deploy, you can train, you can deploy, you can do the whole pipeline, even then monitor, visualize, etc. But problems, in my point of view, is if you want to go outside of the standards, so outside of the normal things they do, it's possible you're not going to benefit much of what they offer. And that's the case of ELSA. We are not using them for the machine learning. We are booting them. We are in AWS now. We are booting machines there, and we are using our own machine learning models inside those machines as if it was just a container, right? So we are not using the specific machine learning service I'll show you in a bit. And then second thing is be careful about cost. They are convenient, but the convenience comes at a cost, and these are normally expensive. So very convenient, very fast to start, probably when you start, but at some point think of, okay, I need to get out of here and have my own servers, or even if I buy the servers from them, but have my own models inside those. A little bit on the three of them. Amazon has a huge offering. They have, and I'm not going to go into every single one of the things, but in all of them they have the two type of column of offerings. In one hand, the left hand is this tool belt or pipeline that helps you get your data in. They sometimes help you label it. Amazon has this Amazon Mechanical Turk, which is a great way. It's integrated in here so that you can get Turkers to label your data. Then you can train with it. They even have, all of them, they have this automated training. In Amazon, it's called Autopilot, which and Amazon is limited to classification and regression. But if you have a classification or regression problem, you're gonna dump the data in there and tell him, hey, give me the best model. And then they go and it tunes, looks at meta parameters, looks at types of models. There's tons of them out there. And then it will give you, okay, I think for your data, this is the best, right? And then you can deploy, do machine learning ops, which is the equivalent of DevOps, but on the machine learning. This is one hand. The other offering, which we are using a lot at ELSA, is the specialized tools they offer. So they have tools for text-to-speech, so generate artificial text. They have tools for image and video analysis, automated transcription of speech into text, automated translation. Even Code Guru is automatically with machine learning analyzing your code and telling you how you can optimize your code. This is pretty interesting, never used it. Google Cloud, very similar thing, 2 columns. Left-hand side, we have this pipeline that helps you prepare the data, build your models, visualize, validate, and then deploy the models into production. And all of this is very nice, right? It's very convenient. You come in with data, put it in there, and you have the whole thing. It's click, click, click. Most of the times, you will not touch a single line of code if your machine learning need is pretty standard. And for, I would say, 80% of the cases, it is very standard. In the case of Google, their automated machine learning is called Automl, and this is something this is something I haven't, I don't have first-hand experience, but it is known that Google is offering a bigger variety of possibilities for AutoML, for automatically finding the best model for your data. And then the same thing on the left, on the right hand, pre-made artificial intelligence modules that allow you to text to speech, speech to text. They have a very nice, well, Amazon has it too. I didn't put it, dialogue, where you can create dialogues like Alexa or Google Home. You can build your own from their UI. And lots of things in vision, text, image, audio, recommendations, etc. The third one, Azure, more or less goes into that direction. I would say it's the third kid on the block, the third player, a bit smaller. At least I don't hear so much buzz from them. And you'll excuse me if you use them and you really like them. I would like to hear about that. Never use their machine learning offerings, but they offer a similar concept. They have this set of automated machine learning ops, tool belt of tools, and also they offer pre-made tools around all these areas we talked about in the Azure Cognitive Services area. Okay. Stepping out on the how to do the machine learning, I wanted to explicitly look into visualization. All these Amazon, Google, Azure, they have their own visualization tools that you can use. And then in addition, there is other companies that also offer you tools. And some of those are very, very, very interesting. So in here, you'll see Amazon QuickSight. This is the Amazon offering. Google Data Studio. This is one that you can actually start using for free. I like it. I like it pretty much. This comes from the Google Analytics era where they derived into this. And then you have external companies like Tableau or Looker, which I've heard very good things about. You hook it to an SQL table and you can actually automate lots of things from it. It's also expensive to use, but it works very well. And I don't have one here for Chart.io, which I heard some companies in Lisbon are using, which also looks very promising. And that's it. So these are the offerings online. And to finalize this section and quickly go into the next section, which is to tell you about my company, what we do with machine learning and the speech technology. I want to show you some examples in real life, both on the hardcore machine learning and also UI UX related. So very classical. You get an image and then you create captions for it. Captions are totally automated. You probably heard of the GPT-3 system now that it just generates text. This is actually something that has been there, automatic image captioning, for a long time, where the input is an image and then it will try to infer what's in the image in a text that makes sense. So recommendations, many people use them in a daily basis. Netflix is the biggest example. I remember 15 years ago, they started with the Netflix prize, $1 million for whoever built the best recommender. And from there, it just took off. The area of recommendation systems just took off, and it's now a very well mature, established area. Spam detection, we talked about that, very old and seamlessly works in your daily life. You are using it every day. And then in the area of language learning, of course, I wanted to talk about this a bit. These are the three big players to teach you a language, teach you from 0 to 100, or I would say to 80, where you're going to learn vocabulary, grammar, and a little bit of speaking. And the machine learning here comes a lot into optimizing how to give you the lessons and what lessons to give you so that it optimizes how you learn. There is a whole background, a whole lot of theory on the learning, how people learn, things like theory like spaced repetition that tells you when you should be reminded of things so that you don't forget them, and how to bring back things that you didn't do correctly so that you can enforce them and learn them. So they use all of that. They also, of course, use the typical tricks to know when they have to ping you so that it's more probable you're going to go back, etc., that, of course, as mobile apps, we are competing in a world where we have so much information around that everybody's fighting for your time, right? So them included. They want to do something good for you, but they have to fight with the Facebook social networks, TVs, or streaming TV, or everything else. And as a different category, I wanted to make it separate because this is actually totally different, is language pronunciation or pronunciation training. You see ELSA here on the right. We have Blue Canoe, a great company. We have Speaking Pal. We have several others that offer apps that teach you how to pronounce, how to speak in English. They don't teach you English, but they teach you how to speak it. And same here, there's a lot of speech technology here. I'll tell you a little bit about afterwards. So I wanted to add these slides to appeal to the people that might be listening today that are not so much hardcore data scientists or hardcore engineers, but are more into the design area and the design of data science tools. And to know that this is very important also. HCI, so human-computer interaction, sits into this triangle between design, psychology, know what the users want, how the users behave, what types of users we have, and the engineering computer science, right? Some examples. This is Clippy. Maybe the first example of some artificial intelligence, even though some people became very angry at it because it was keeping popping up and, oh, you seem to have a problem. No, shut up, go away. But it was one of the first attempts for Microsoft to infer what the people needed and then help them out, okay? These are also early attempts to visual search. They are ugly to hell, but those were attempts where we have a data science problem or machine learning problem, which is find videos that are related to either some query or some other similar video, and how do we visualize this? How do we show it to the user so it's fast to find? You see down here, down left, a sort of a pyramid where you have videos related in different dimensions, which could hopefully help you find the video very fast. And then more recently, all the voice interfaces, all the voice applications, they need to have lots of either design visually, like the ones that go into the mobile, or design in terms of the right way to speak to people. So in conversational interfaces like the Google Home or Alexa, it's very important to know how you talk to people, and that changes different depending on cultures and depending on how you intervene, how you interact with the machine. Okay. Um, Finally, I wanted to mention here some robots that have come to be and then to stop being, like this guy here in the middle that's no longer available, but robots that show us that these future of the robots that I showed you at the very beginning could be getting somewhere, but I imagine it more like this guy. I think his name is Sophia on the left. It's just a prototype. It will take a long time until we see lots of them in the street. But the one on the right is an actual robot that actually helps elderly people feel much more empowered. I don't know if empowered is the right way, but it gives them self-confidence more, because it gives them company. It reacts to their emotions. They pet them, they react. So it's sort of a personal pet that you don't need to take out to the street every day or give food to. Just put the batteries and it works. Finally, lots of machine learning into social networks, and I would say use at your own risk. If you haven't seen it, check the Social Dilemma. It's a very nice documentary from Netflix, talking about how social networks have become to use a lot of machine learning to try to predict what you want and to try to actually make you do what they want, even if you don't realize that it's them that are acting on you. And you have Cambridge Analytica on not the previous election, but the one before 2016 in the US that explains that. Okay, so if you are still in for about 20 more minutes, I would like to explain to you what we do at ELSA. And thanks for the 18 people that are still around. And I would really like to explain to you as deep as we can on what we do at ELSA, how relevant is the machine learning we do, and all of this we do mostly with a team I have here in Lisbon. So what's the speech signal? So ELSA is all about a speech technology application, and we get the audio from the user speaks to the application, and we identify what the user said correctly or said wrong. So first of all, to understand that, we need to understand what tool we use, what the tool is the humans we use to speak. And this is very simple. We have a generator down here, which is the lungs, that create air that then will resonate around all our vocal cavities, nasal and vocal, and will get out of our mouth. The larynx, the vocal cords. What is the vocal cords here? Over here. The vocal cords make the difference between voiced and unvoiced sounds. So it will help us create the f sounds and the sound, which is voiced and unvoiced. So if we put it into a machine, it's sort of like that. So we can generate unvoiced sounds, so noise, or voiced, which is pulses. And then there is this sort of digital filter, which is our vocal tract, that will create the speech that we get out. Now, we need to make a machine that inverts this and then uses this speech to analyze and derive information from it. Just to tell you here that speech signal is very, very hard thing to process. And some people say, image is harder. Well, maybe, but speech signal is a hell of a hard problem. So speech, in addition to the message, so to the linguistic information, to what you want to say, it also conveys a lot more information, like who said it, what's the mood he was when he said it, what's the health of the speaker when he said it. You can identify if the user is healthy or not. Sometimes you ask somebody, hey, you have a cold because I feel your voice is very different. accent, so where they are from, or what's their mother tongue, even if you're speaking a different language. I'm sure you feel an accent in my English. And as I said, it's very hard thing to process because you have lots of variability. Every speaker, every person speaks differently. Every microphone that records your speech modifies it in a different way. The place where you're speaking has different reverberations. This is the channel. So the room I am in, it reverberates the signal. The transmission, the digital or analog, it changes the signal, etc., etc. So, for example, this is a word that's called Oceania, spoken by 4 different people, and every person speaks it the same, but the signal is totally different. So there is a lot of areas in current research in speech, speaker recognition, text-to-speech, so generation of speech, speech-to-text, understanding speech, paralinguistics. If you're intoxicated, if you have cognitive disorder, some pathology, if you didn't sleep, things like that. Assessment, this is what ELSA we do at ELSA. We assess your speech, whether you're speaking correctly English or not. Conversion, so going from one speaker to the other. So the state of the art allows, it's getting very good results at getting somebody speaks in one voice and then it converts and you're basically speaking, you're hearing yourself in another voice, and many others applications. So let's go into speech recognition. I'm not going to go into the detail that is here. I can send the slides afterwards to Tiago, see if you can get the copy if you want. But we've evolved a lot since the early 60s, where there was no machines. Everything was done with punch cards, and up to nowadays, 2000 and beyond. And normally I show, these are showed in the speech community a lot. These are many different data sets on different types of environments recorded in different ways, and how over the years, this down below is the different years, over the years the performance keeps improving. So this is 100% error, 0% error, and around 2 to 4% would be the human capacity to this. The task is to do speech recognition, so to translate what you hear into text. So humans make mistakes from 2 to 4% of the time. We've been far from it for a long time, okay? But recently, we're getting another one here, same thing. Recently, we are seeing in some tasks that we are getting to very close to 0. So in this case, I think the state of the art on switchboard is about 4%. So it's already on the human level. And here another data set, read speech, recorded read speech, we are already at 2.5%. So very, very close. That means, that's to say, speech technologies has become to a point where it's definitely usable for commercial applications, for real life applications. Before, 10 years ago, 15 years ago, there was a hype in speech recognition, but the technology was not ready. So lots of actually speech research labs closed down because they were, the companies didn't support them anymore. They didn't accomplish the promise they were doing. Nowadays, it's the contrary. Lots of speech research is coming up, lots of people pouring into the area because it is actually working. And we'll see what the future brings to us. Some people say it's going to be a machine learning winter. We'll see. We'll see how the deep neural networks allow us to grow or not. ELSA. ELSA, this my company, the company I founded with Vu Van. It's a woman from Vietnam. We started 5 years ago, and we have offices in the US, here in Portugal, India, and Vietnam. We're about 90 people right now, and we have an application, iOS and Android. You can see a screenshot here. You'll see more screenshots afterwards. That it's been downloaded by more than 10 million users from all over the world. It's in the App Store and the Google Play Store. And we've, since the start, helped people play about 700 million exercises. So 700 million times they went into the app and recorded a sentence to get it evaluated and get their score. I'll show you a little bit more what the type of exercises we do, which is like sound pronunciation, sentence intonation, word stress, listening, spoken fluency. These are the different things we teach. So we teach people how to pronounce correctly in English. The interesting things here is that we go down to the detail and try to identify the exact problem that people did and give them feedback how to improve that problem. So by practicing into the app, you are actually having like a live coach, a live voice therapy coach that helps you reduce your accent or improve your intelligibility in speaking English. These are some examples.
Just to give a very quick note, we have a couple of questions that I would like to cover 5 minutes before we finish. So if we could.
So we have until 11:30, right, maximum?
The webinar is booked until 11.
Oh, 11 only?
Yeah.
Oh, I'm sorry. I thought we had 2 hours. Okay.
Yeah.
Cool. Okay, then let me wrap up. Okay, let me wrap up. We have different types of applications. Listening, conversation, different types of things. I would show you examples of people that come into the app, but I think it's better to move forward. And well, to give you a little bit of overview, we do signal processing in the pure style of signal processing. So we take the audio from the phone, we go into our, we stream it to our servers. Our servers will process it. If the audio, we don't know what it said, we will use a speech recognition engine. And we are training speech recognition engines for each one of the non-native speech, because this is one of the biggest problems in speech recognition. When somebody that has a big, strong accent speaks to it, normally it's not well understood. And then we use our assessment engine to give back to the app the feedback on how they said it. Let's skip the machine learning part. Let's skip, I'm telling here a bit of what the theory behind how you do language assessment works, where you compare what you said and what we detect you saying with what you should be saying, which is what we expect you say, given that we know the pronunciation that is expectable for the words you said.
Okay, Javier, Ines just correct me. This is actually 2 hours. For some reason, I have only 1.5 hours in my calendar. So everyone in the audience is expecting 2 hours. I'm sorry about that.
No worries. No worries. Anyway, I skipped some parts. Let me just go to show you. I don't know if you can hear the samples. Tiago, let me know if you guys hear it. I don't know how the GoToWebinar works.
Yeah. No, we can. With
2 of my best friends. We will go sightseeing and stay at the resort.
So this is an actual user of the app, somebody that has a pretty decent English and that will use the app to perfect his pronunciation on some of the small mistakes he's making here and there. Let's think of let's take into account that an app like ELSA can help you reduce your accent, but the most important thing that we aim at is to make you enable you to speak English and enable you to communicate with others. So the intelligibility part is very important. By using ELSA, we aim that you will lose your fright to speak in public in English, and you will be understood by others. So this person will be understood, and he might want to polish some of the defects. On the other hand, if you go to the other corner of the spectrum, we'll have somebody like this person.
This summer, I will visit a new country with 2 of my best friends. We will go sightseeing and stay at a resort by the sea.
So it's very difficult to understand this person. This person, it's not that he doesn't know how to read, but he doesn't know how each one of the words is spoken, and when he pronounces them, he drops some of the sounds, or he doesn't pronounce them correctly. So this person benefits a lot, and we see a lot of improvement over a short period of time once they start using the app, because they realize how things are spoken. They realize they tune their let's say their what we call the muscle memory on how the sounds are pronounced in English. Okay, so this is what we aim for, and we went to here. So yeah, let me spend a minute here. So this is a pipeline on how our whole machine learning works, and here it focuses on the pronunciation gains, which is where we actually see a lot the most benefit to our users. So we'll start on our backend. We have a tool that allows us to create content. In this content, we will add the definition of the word or the sentence that we expect the user to say. Here it's on the same page in this case, and we will add reference audio, so you hear an American person speaking it. We will add translation in different languages, etc., etc. This will create a set of lessons that you can see on your device that you can click on, download, and start playing. Okay, this is all on cloud, and it's only downloaded on demand to the devices. And the device then will start playing. So then you see the screen on the left part. You click the microphone, you start speaking the sentence, and the audio will be streamed into our servers. Then it will be processed, normalized, prepared, and it will enter into our deep neural network. This is one of the parts where we get phoneme posterior probabilities as an output. So we get several thousand outputs here, and then we post-process and the input is the audio signal, the acoustic features extracted from the audio signal. So we will process it. The process here is totally online, meaning that the moment the user starts speaking, we already start processing the audio. Why is it? Because we have a nice feature that the user finishes the sentence. He can, if he wants, he can stop the microphone. If he doesn't want to, he just waits, and the server will stop the application will stop the moment that the server has already an answer for you. And that happens within 1 or 2 seconds of when you finish the sentence. So you say that, and then the backend processes your audio, will take into account specific rules, whether dependent on your mother tongue, dependent on the types of errors that you're making, and it will create the feedback back to you. And this feedback will include something that is very interesting, which is an automatic generation of feedback hints. So based on the error we detect, we run several classifiers there to determine why you made that error and in which way you made the error, and then we'll generate text plus audio. The audio is automatically generated, is text to speech, that gives you feedback on how to improve it. So the feedback, that's what is explained here a little bit more. It depends on the expected versus detected phoneme you pronounced, the context of the phoneme, how many times you said it, you practiced it, because we want to give you different feedbacks every time, and your mother tongue. So it depends on all this, and it goes, for example, the L here is pronounced with a strong L phoneme sound. Please say the word, I don't know, loud, right? Whatever, and so etc. etc. All this feedback, actually we translate it to several languages. We already translated in Portuguese, and we have Portuguese, we have Japanese, Vietnamese, I forgot some, and well, it's one of the parts of the AI that we are providing to the user so that he improves. The biggest AI part is on the detection of what we need to tell you. On the acoustic modeling side, so although that deep neural network, many people always ask, what's the difference between what you do and speech recognition? And this is what it is. In speech recognition, you want to identify what the user said no matter what. So you have a strong accent. What you expect, what you hope is that speech recognizers like the Google Home Alexa will understand what you said, even if you said it very, very strongly accentedly. For us, it's totally the opposite. We need to have, and we use something called multitask learning. We need to have a double standard. On the one hand, we need to know exactly how the phonemes, how the sounds are pronounced in English. So we train a full neural network with an ending branch, which is the English pronunciation, and that's our targets. We want to predict how well each one of the English phonemes are pronounced. On the other hand, on the other ending arm, we have our own user data that we have collected over time, and we have thousands of hours of it, that allows us to train how the users actually say it, and most importantly, in what acoustic conditions, what microphones, what channels, etc., etc. And all of this, it helps us tune this inner part, this common part, so that it optimizes for both branches. Now, then in production, we don't use this. This is what we would use for speech recognition, the user data, the user branch, and we use the pure English branch, which is able to identify how well you said the English phoneme based on what we know of American English phonemes. A bit of talking about infrastructure. This is important because, as we talked before, all these different providers, AWS, Google, Azure, and others, they are providing you with a pipeline to send your models to production. Why do they do that? Well, they actually do that because sending a model to production is hard, is very hard. You can have your models working perfectly on your laptop, on your IPython notebook or whatever, but the moment you have to put them out there to the users, it becomes a big engineering problem. And some of the things you have to take into account are cost efficiency. You cannot just put something that takes lots of machine. You have to optimize it as much as possible. Response speed, so how fast you are at responding, how often it crashes. If it crashes locally one time, it's fine, but that means that online it will crash every 20, 30 users, and that's not okay. How fast you can scale up. So if you all of a sudden have 1,000 users, will it scale? How will the system scale? And then things, unfortunately, we need to look at, which is denial of service attacks, API exploitations, make it secure, and etc. Because this is a problem that the moment that you appear on the news or the moment that people know you, there's going to be somebody that in their free time will try to attack you. We use Kubernetes. We are very, very happy with Kubernetes. We host them in AWS. We could host them anywhere else. For those that don't know what Kubernetes is, it's something that is an open source environment system. I don't know how to define it, that Google open sourced, and it's a way for us to manage our infrastructure so that all the scalability and monitoring of our systems is taken care by them. And we are running basically Docker containers inside Kubernetes, and the Docker containers themselves scale or get rebooted whenever there is problems, etc. Before that, we had to wake up many times in the middle of the night because we had tons of alarms on our phone because things were stopped. With Kubernetes, we started sleeping much better. On the UI UX, I want to mention a bit that, because that's very, very, very important. You know, your application, we have a B2C offering. We also have B2B, but I think I'm not talking about that today. We have a B2C application. The users will download that, will look at it. If they don't like the look and feel, or if it seems confusing, they will not use it. And then all this effort of the data scientist, of the machine learning person, just goes to waste. So you need to have a very pleasant UX, easy to understand, and something that in our case is effective at teaching you doing what we want to do, which is teaching you pronunciation. So plenty of information, good and variety of feedback, good quality and good variety. And then at the same time, you want to also try to optimize for, of course, retention, engagement, monetization. So you want to make it so that the company actually moves forward. And finally, there's something that I mentioned before, all these Babels and Duolingos of the world, they also do, and many apps, gamification. So you need to make the user feel engaged with the app, and so make them come back. They have many different triggers try to steal our time. We have only 16, 18 hours a day, so want to steal our time. So we need to have leaderboards, ways to do content that appeals the users, and then push notifications when they need to come back. All these things, they need to put it into place. These are some screens that they keep changing. This is from our app. We have a sort of a planet theme where we are these astronauts that goes into different planets. Each planet is a skill that we want to master. This is from the very beginning of ELSA, and sometimes we've discussed whether this is still relevant or not, but still there, and it's still, I think it's working, it's nice. It's in between of a game and a professional tool, so something that doesn't feel too stiff, but doesn't feel like just a game. We have tons of topics. We have a way to see them now. This has recently changed. It has a different look now. And we have a coach. Means somebody that recommends to you every day what lessons you should do. This is totally tailored to you. We look at your skill. We look at what you should improve in terms of what phonemes you are lacking, and we give you lessons for those. We have a mode where people can actually create their own lists. I don't know if you've heard of Quizlet. They let you create and share lists. So we went into this sort of idea, and some people create lists, and you can vote on them, you can share them, etc. We have a dictionary where you can type whatever you want, or you can speak whatever you want. We will understand it, and then you can practice on that. And then we have all the evaluation ways. So people need numbers. People want to see how they are doing. So we have our Pentagon scoring. We score pronunciation, listening, word stress, sentence intonation, and fluency. And we give you a score for each one of them and an overall score. We also have in here in the top right, we have an assessment test where you are evaluated when you start the app, or whenever you want, you get evaluated. And in there, we evaluate your skill on intonation, fluency, and pronunciation. That's when you read the sentences that we propose. And very recently, we added in here an estimation of your IELTS score, which is a very famous IELTS, very famous exam of people taking that is used like the TOEFL or the other exams for English speaking. And in the middle here, the word bank, Banco de Palabras, in here we keep all the words that you've done very well, or that you should be improving because you haven't done very well in the past. So this is a bit of what the app looks nowadays. It's already a bit outdated. This is 2 weeks ago, and we already implemented some new things. But just download the app, it's free, and you can test it. Sort of to the end of the talk, I wanted to talk slightly bit about linguistics and content, because this is a very important part of ELSA that me and my team as a machine learning scientist, we have to know a lot of linguistics, because that's what we are teaching people. And we have actually nowadays, we have 3 linguists, 1 phonetician, 1 voice therapist, and 1 general linguist that are helping us create the best content possible and make sure that the content works well. So it all starts here. This is the International Phonetic Alphabet, and the ones in blue are the sounds in English. All the ones that are not in green. All the ones that are not highlighted are all the different sounds, or most of the different sounds that people can do in their mother tongues. So we have to identify the green ones if they are pronounced well, and we also need to identify somehow the other ones to see what type of error users make. How is our content creation process working? So we have a linguist. He uses his imagination and some Excel sheet first, and then the online tool I talked to you about before to create content. So we know the topic we want to write about, we know the skill, so what kind of sounds we want to teach, and any specific requests like, yeah, make it long, make it difficult, make it easy, make it whatever. Once it's written and verified, we have a voice talent that records the audio so that the users can listen to the audio in American. And then we validate everything semi-supervisedly to make sure that all this is correct, and we modify anything that is not correct. All of that is uploaded and QA'd on the app, and then once everything is ready, then we put it online, and then the app downloads it on demand, right? We are doing this pipeline, we're doing it several times every week right now. So there is content, new content every day. This is outdated already to a couple of weeks ago, but we have, let's say, some of things like about 2,000 exercises, 2,500, 12,000 exercises, 2,500 lessons, unique lessons on many different topics, 75 topics like relationship, travel, changing careers. Now we have some topics on shoes, shoe industry. Some company really wanted that, so we made a bunch of things about shoes. So you can learn everything about shoes. You can learn about investing, stocks, etc., etc. And that's it. Thank you for your attention, and I made it on time. I hope we have time for questions. So Tiago, you want to take over, and thanks for your attention. Yeah.
Yeah. So yeah, Javier, thank you for this awesome presentation. I think it really provided the goal that we had in mind when we talked in the beginning, which is delivering a good presentation about the introduction of AI, the state of the art, and we could go a little bit deeper about what you're doing. For the interruption in the beginning, I was just got the calendar wrong, and I thought we were going to be short on time.
No
so for the questions, we do have a few questions from the audience. So I'm going to jump straight to those, and then I will probably ask also a couple of questions that I have regarding this area of data science and the way we can introduce it into projects, which is what we're trying to do at Imaginary Cloud. We are currently creating a department on data science. We are creating our process to develop data science, and a lot of the problems that we will be facing and that we are facing now in the beginning is always trying to understand what takes from a good development, a good design to move it into production. And we actually have a question in here regarding that. So the first question that I have is on the data science three bubbles model. So I believe that this is the slide where we have the deep learning. Sorry, the slide where you have the three bubbles is, if I'm not wrong, is the slide where you have the supervised, unsupervised, and
okay, reinforcement
learning, right? So the question in here is, what is your take that a data science lab needs a programmer to translate the algorithms into proper best practice code? So the question in here is, you have developed the model, or you have designed the model as a data scientist, and then you will need to move it into production. Do you actually need, from your experience, and I'm talking about the majority of the data scientists, not your particular case only, but what you've seen from the data scientists, do they need a developer to be working with them and then to help them move that model into production with the best practices of software development, making sure that the code is optimized to run into production, not just the model? What is your take on that?
So my take, yes. A data scientist or a researcher. So data science is, as I said, is a new term nowadays. Is a fancy term, but at the end of it, machine learning practitioner. You normally, what your objective is to make the model learn and to get the output to be as good as possible. So that's your objective. On the other hand, the objective of a developer that develops products for customers, for end customers, or to put in production at large scale, is to make systems scale, to make systems cheap, fast, all these other things. These are totally two opposing views of that. In the middle, they have the actual implementation. So they have the actual system that they wanna. One side they tries to create it so that it works the best, gives the best results. The other side tries to implement it and wants to make it optimized, fast, whatever. Now, traditionally, these two guys wouldn't speak to each other, would hate each other, or would the data scientist, the engineer would say, "Here, I'm done. Here you are," and then the developer would take it and would try to productize it. More and more, and Google started doing that a long time ago, where they stopped calling lots of people with PhDs and stuff, stopped calling them scientists. They call them other words, and they charge them with the role of, okay, your model, your system should be as close as production ready as possible. So of course, you sometimes still, many times still need a good developer that helps you get the extra 20% improvements there to make it for a most optimized production. But more and more nowadays, we are getting that closer and closer. So the researcher tries to make the final model as close to production level as possible. At ELSA, we don't have the luxury to have many of all the types. So our actual researchers, they actually push things to production directly. Of course, we have several researchers, all of them bring in their different expertise, and all of them do pull requests and help each other to make sure that it's just not a big problem. And then we have an engineering scientist, an engineer that is working closely with us, that helps us improve that, right? But no. So long story short, you should aim at having researchers or having data scientists do as good as possible, aiming at production. But don't expect it perfect. Don't expect it optimal, because the objective function, what they try to optimize, is totally different.
Okay. So would it be useful to, when you have data scientists developing the models, would it be useful to put them as part of a development squad, and they will just focus on the data science part, but their code could be reviewed by developers when they make a pull request to production, so they would participate in the same rituals that the developers participate? Is this valuable?
There is a lot of thoughts on that. I think it's helpful, but you have to be very careful with the timelines. If you do rituals like sprints of a couple of weeks, that's very short for a data scientist. I know some companies do it. In my company, we do 1 month sprints for research and 2-week sprints for development, and that works pretty well. Now, yes, it is important that the researcher doesn't close himself into his castle and just opens the door from time to time and spits out a model. No, it's good that they are integrated, so they know, they also interiorize the caveats and the things they should be looking at. And because at the end of the day, data scientists should be, you can get to data science from many dimensions, but many data scientists nowadays, they come from a computer software background, so they can understand that, they can adapt to that, and they can make the life much easier to make things very close to what the actual final product is.
We actually do an experiment in here, not an experiment. I mean, when we are recruiting, so our recruitment process is always 3 stages, and the last stage is pair programming. And whenever we get a data scientist to the 3rd stage, we put a developer there as the pair programming session. And it's really interesting, because we've seen even the most brilliant data scientists, and even when they come from software engineering, if you have a senior developer with them pair to pair, then I mean, it's not the mistakes, but it's the lack of good. For example, if they do a recursive function, we see a lot from the software development that there are a little bit of pitfalls that they run into, and the code is not optimized, and they have a little bit of trouble of optimizing that. While a developer would just say, okay, so if you put this model a little bit different, then it will run much faster. So we actually see a little bit of benefits of having a developer in there, but I agree with you. I mean, if the models, especially in the early stages, I mean, the models are they actually going to be massively running into production and impacting a lot the rest of the application or not? Because if it's a lot of work on the background, then probably it can be done with a little bit less performance.
Yeah, but be careful, because when you do that, when you put a developer in the room when you are interviewing a data scientist, if you then listen to the developer a lot when you're trying to do your judgment whether you hire that data scientist or not, you're not going to optimize your objective. If your objective is to hire the best guy on data science, that's not going to be the best guy on software engineering.
No, that's true. And the goal is not that. The reason why we put the developer in there is to be a little bit of sound and understand, I mean, if that code can actually be useful or not, and if there can be an interface with the rest of the engineering team. What I'm saying, so the goal is not for the developer to vote if that person should go or not, because there is a lot of discussing the problem, what solution the data scientist is going to apply. We're not looking for the best coders. What I'm saying is there are a lot of basic mistakes because the mindset of the data scientist is not on the best performance of the code.
Absolutely not.
Using
Absolutely
the
not.
best. Even sometimes the libraries, a developer can say, just because they use Stack Overflow better to find tools, they can say, I think you can use this library to do this little part of the code. So we've seen a little bit of benefits, especially on these interview sessions, of having both in there. But I also have this mixed feeling. I mean, if resources are limited, what is the impact of the model that's going to have in production if it's not optimized? Can you live with that and move faster or not? That's the point that I mean, I've seen taking a little bit into consideration. But in terms of your current data science team, so you have the data scientists working completely separate because they are on different sprints. They are separate from, they have a different roadmap, and you don't have any developer in there. So it's just the 3 data scientists in the same squad doing 1-month sprints.
Yeah, I mean, the current setup we have at ELSA is we have separate teams, and it's not optimal in some ways because you can end up with you can finish some models and some models you can finish a new feature, a new technology, and then you don't have anybody on the other side ready to take it and implement it in production because the timelines are different. So we're working on how to improve that, and it's a very typical problem, and it also comes with it comes because of another issue which we haven't touched, which is the how much of an incognita, for the lack of a better word, how much of an incognita is when you are developing a machine learning model. So they ask me, okay, develop a model to do X, Y, Z. Fine. So then I ask, a researcher starts working on that. And then after a week, he'll tell me, that's complicated. After 2 weeks, he'll tell me, yeah, I tried a few things, don't work. After 4 weeks, they'll tell me, yeah, it's done. But I cannot predict when I give them the problem that it's going to take 4 weeks, or it's going to take 4 months, or it's not going to be possible. So you have to take that into account and measure it very well when you are scheduling your timeline with the development side. Where in development side, things are very much well defined. You can define a project in a way that, okay, you're gonna, at the end of the 3 months, you have to deliver to customer, and that give or take plus minus 10%, that's what you're gonna deliver to them. But in machine learning data science, it's very complicated to estimate.
Yeah, there's a lot of research doing in the strategy on the roadmap. Okay, thank you, Xavier. I have another question. So, when you are dealing with speech, how do you deal with the variability of speech? So the speaker change, or the channel, or the acoustics change, when you basically have new conditions that were not present in the training data set. Do you do any kind of domain generalization technique or data augmentation on the speech to process those new variables? How do you deal with this?
Yes. Nowadays it's simpler. In the past, I'll tell you nowadays in a minute. In the past, people had put their brains and done lots and lots of filtering, lots of signal processing. Like there was a lot of knowledge in signal processing put into the area to normalize the vocal tracks, so the vocal tracks would all have the same equivalent length, normalize, and put filters to take out noise, to normalize background problems, etc., etc. Nowadays, it all comes down most of the time to having more data for the training. So there is in deep neural networks, you put more layers, more hidden layers, you put a lot more data, you make sure the data covers all the possible cases. So of course, if you have totally out of domain data, you have a problem. But if you have in domain data, and we have lots of it at ELSA, as I mentioned before, you can actually get your system to train to all specific possible variations. Like, I don't know, there is a bus passing by. You have tons of people that were recording with buses passing by, or they are in a room that has a huge reverberation, same thing. And then another thing you do is, which is helping a lot in speech, is you do data augmentation in terms of you modify the pitch and you modify the speed of the speech, and you also add noise, additive noise. So you have these three variations, and that sort of explodes your data. If you had 10,000 hours of data, all of a sudden you have 30 or 40,000 hours of data, and you fit all that in there. You put it into a big machine, lots of GPUs, wait for a few days or weeks, and then here you have a model.
Okay. Thank you. Okay, so I think we can wrap up. We are almost on time, and I think it was a really good session. So I'm just going to say goodbye for now to the audience. I hope you enjoyed this. Please, we tend to organize these master sessions on a regular basis, and we hope to have people as interesting as Xavier has been on this session. I know that it's not hard to find the topics, but we'll be able to go through that and bring you relevant topics. So keep an eye on our newsletter. Javier, again, also thank you for being here. You have Javier's email on the webpage, so if you need to ask any specific questions, I'm sure Javier will be able to get back to you if he finds time on his agenda. And again, Javier, thank you for being here. Also, thank you for Inês that has been on the background organizing the webinar and supporting us on these sessions. She's not visible, but she's here helping us. So thank you also, Inês, for organizing this. And I hope to see everyone here soon.
Thank you, guys.
Thank you. Cheers. Bye.
Bye.